This pencast covers domain for college algebra. I am Lisa Cohen. So the domain is the set of allowable x values. And by allowable, that means that we can't divide by 0, and we can't take even roots of negative numbers. If I give you a polynomial x squared plus 5x plus 6, notice how there are no denominators or variables in the denominator. And we don't have any square roots or even roots. The domain is all real numbers, or in interval notation, negative infinity to infinity. Our next example is 1 over x. Notice we have an x in the denominator, and this means that if x was equal to 0, we'd be dividing by 0. So x can't be 0. If we write this in interval notation, that means that we can start at negative infinity, don't include it, so we have a parenthesis, up through 0, not including 0, or from 0 to infinity. Our next example will be slightly more complicated, but 1 divided by x minus 4. To figure out what the domain is, we set the denominator equal to 0 and solve for x, and what we get is x equals 4. If x were 4, we'd be dividing by 0. Really, this is what x can't be. We're omitting that 1 point from the number line. So right there at 4, we have an issue. So our domain goes from negative infinity up through 4, don't include 4, and then 4 to infinity. So there would be a skip in the graph, discontinuous there. You'd have a vertical asymptote. Just boxing in these answers. Let's try another one. F of x equals 1 over x squared plus 5x plus 6. What we're going to do is we're going to set x squared plus 5x plus 6 equal to 0, and we're going to solve for those values. And we want two numbers with a product of 6 and a sum of 5. Those answers are 2 and 3. If we set each factor to 0, we get x equals negative 2, x equals negative 3. Would solve that equation, and those are the values that x can't be. So our domain is all real numbers except for negative 3 and negative 2. So it could be between negative infinity and negative 3, or between negative 3 and negative 2, or from negative 2 to positive infinity. Next example will involve a radical. This is true for even roots, but we have a square root here, and we know we can't take a square root of a negative number. We would like to keep the domain real. And so our domain here is that x has to be greater than or equal to 0. If we write that in interval notation, we can include 0, and so it goes 0 to infinity. These are the set of allowable x values. Now if we change this and put it in the denominator, try f of x equals 1 over the square root of x. This time we have two issues. We have a variable in the denominator, so the denominator can't equal 0, and we need the radicand to be positive. So what we want here is for x to be strictly greater than 0. Because of the denominator. It can't equal 0, or you'd have 1 over 0, which is undefined. Therefore, our domain this time is 0 to infinity still, but we're not including 0 in this example. Next example, f of x equals the square root of x minus 5. We don't have any denominators. Then what we want is for the radicand to be greater than or equal to 0. If we solve for x, what we get is that x is greater than or equal to 5. So our answer here, or our domain, is that it starts at 5, it includes 5, and it goes to infinity. That's the domain of this function. Similarly, if we write it in the denominator, we have f of x equals 1 over x minus 5. That's the radical of x minus 5. This time we have variables in the denominator and a radical, and so what we want is for x minus 5 to be strictly greater than 0 this time. And if you add 5 to both sides, what you get is that x is greater than 5. So the domain of this function starts at 5, doesn't include 5, goes to infinity, and that's the answer. Anytime you're trying to find the domain, you can't divide by 0, and you can't take an even root of a negative number. Those are the only things you need to consider.